Hi, so if you're watching this, it's very likely that you've been told in the lesson today that you're going to have a test to see where you are at the start of year 11 next week. To help you with that, this is the test, and I'm going to talk you through the answers to this, so or talk you through the workings to this, so hopefully you can do really well on that test next week. All these are absolutely classic standard questions that if you that you really do need to know for 1 year's time when the real GCSE is here. So without any further ado, question one. Aluminium has an atomic number of 13. The atomic number, that's the number of protons in the nucleus, the number of positive charges in the nucleus. That number of protons never changes in chemistry. And it has a mass number of 27. Now, if you remember, the electrons are virtually weightless, so this mass number of 27 means there must be 27 other particles present. Okay, now of those we know 13 are protons, that hasn't changed, so the other 14, because 27 minus 13 is 14, the other 14 must be neutrons. So the question says, calculate the number of protons, neutrons and electrons in the Al3 plus ion. Now there's a sting in the tail here, because it asks for the Al3 plus ion, not the aluminium atom, so be really careful. You often see these numbers written on the periodic table like this, with the Al, the 27 there, and the 13 there. The 13, that's the atomic number, that's the number of protons in the nucleus, and that never, ever, ever changes. So we can put 13 down there straight away. The neutrons. Neither of these numbers tells us the number of neutrons present, but this top number, the mass number, that's the total number of protons and neutrons present. If 13 of these 27 are protons, then 27 bells go in school. 27 minus the 13 equals 14 neutrons present. So 13 and the 14 added together make 27. That's the mass number. So it's 14 neutrons. The electrons. If this were an atom, the number of protons in the nucleus, positive charges, must be balanced exactly by the number of negative charges. However, this is not an element. This is not an atom of the element. This is the ion. So what this basically means is we've got 13 positive charges. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. Now, in the element, there is an electron balancing out every single one of these negative charges, every single one of these positive charges, essentially cancelling them out. What we've got here is a 3+ charge though, so we're not going to have all 13 electrons. We're going to be missing some because there's going to be positive charges left on their own. So you can draw negative charges all the way along here until we have 3 positive charges left on their own. That's the 3+ ion. So count the electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. 10 electrons. The fact it asks the ion, that's the sting in the tail. Don't fall for it. Silicon has an electronic configuration of 284. What group and period of the periodic table is it in? So, periodic table. Okay, what you need to remember, of course, is that groups go down. This is group 1, group 2, group 3, group 4, 5, 6, 7, and it's not 8, it's called group 0. I always say because they react with nothing, so it's group 0. Periods, they go across in the periodic table. Don't forget period 1 is hydrogen and helium. A lot of people forget that because it's only got 2 elements. So that's period 1 there. Period 2, period 3. Okay, so using that logic, hopefully you can tell us what group silicon is in and what period silicon is in. Silicon is here, this element. Okay, so remember, the groups are vertical, the rows, the periods are horizontal. Okay, you tell us what group and what period silicon is in. The formula of iron 3 chloride. Iron 3. This means here, that tells you that 3 there, the 3 in the Roman numerals, that tells you the positive charge on the ion. So that is going to be Fe3+. Now, the periodic table tells you the formula of the chloride, the charge on the chloride. Again, let's get the periodic table back out. So chlorine is here in group 7. Chlorine is there, it's in group 7. That means that the group number tells us the number of electrons on the outer shell. So chlorine has got 2 electrons on the first shell, 8 electrons on the second shell. 2 and 8 make 10. The atomic number of chlorine is 17. So that means 2 on the first, 8 on the second is 10, so there must be 7 electrons on the third shell. 1, 2, 3, 4, 5, 6, 7. 7 electrons on the third shell. And the group number tells us 7 electrons on the third shell as well. Because it's got 7 electrons on the third shell, to get a full outer shell of electrons, which of course all elements want to do, it's going to want to gain 1 electron. It's going to want to gain 1 electron. Now electrons are negatively charged, so it's going to want to gain 1 electron. So every time the chlorine forms the chloride ion, it gains that electron, it's going to have a single negative charge. And this is the same for everything in group 7. Everything in group 7 has a single negative charge. Following that logic, everything in group 6 is going to have 6 electrons in the outer shell. Every ion in group 6 will form a 2 negative charge, and every ion in group 5 will have 5 electrons, and every element in group 5 has 5 electrons in its outer shell and will form a 3 negative charge. Okay, so the periodic table tells us the charge on these elements when they form ions. It works with metals as well, of course. Everything in group 1 has 1 electron in the outer shell. The lithium, for example, 2 electrons on the first shell, atomic number of 3, so 2 electrons on the first shell, 1 electron on the second shell, is going to want to lose that 1 electron, get rid of it, so it will form a 1 positive charge. Every element, when it forms an ion in this group, forms a 1 positive charge. Likewise, group 2 a 2 positive charge, group 3 a 3 positive charge. The transition metals, these are different. These can actually form different charged ions. They're said to exist in what's called different oxidation states, variable oxidation states. So we don't know what charge these ions form. Okay, that's why there's always a Roman numeral when a transition metal is written. Look, there's iron. We don't know what charge it is, so it has a Roman numeral after when it's written. That means 3+. Chlorine, group 7, Cl-. Now, when writing these formulae, these charged ions, these charges must balance. So at the moment, we've got Fe3+ and Cl-. So we've got 3 positive charges and 1 negative charge. The charges must balance. So we need 3 negative charges to balance 3 positive charges. So we must have 3 chloride ions. 1, 2, 3. So the formula, therefore, is going to be FeCl3. So next question. What's the formula of lithium oxide? Formula of lithium oxide, using exact same logic, we need to find the periodic table to help us with this. Lithium here on group 1, so it forms a 1 positive ion. Oxygen here on this side, oxygen over here. Group 6, so it forms a 2 negative ion. Okay, group 0, if you remember, these react with nothing because they've already got full outer shell, therefore they have no ions at all. 1 minus for group 7, 2 minus for group 6. So it's going to be, the periodic table tells us this, you have to look at the periodic table to answer these questions. You can't just know it. You can't just know it, you have to look at the periodic table. So lithium group 1, hence Li positive. Oxygen group 6, O2 minus. Okay, so what we have to do is make these charges balance. Okay, so we've got a 2 negative charge, 2 negatives, and we've got 1 positive. So we're going to need another positive charged ion. There we go. So I've got 2 lithium ions, 1 oxide ion, hence Li2O. Formula of aluminium sulfate. Okay, back to the periodic table, so we need to know about aluminium. Aluminium is over here. Aluminium is over here. It is there, group 3. Okay, so it's going to form a 3 positive ion. It's got 3 electrons in the outer shell, the aluminium element, atom of the aluminium element. It's got 3 electrons in the outer shell, so we need to lose 3 electrons, hence it's a 3 positive ion. So it's going to be Al3+. Now, it does rely on you knowing some of these more complex anions. A more complex anion, it's made of 2 elements. Sulfur, 8, the ending means, and oxygen. So the sulfate ion is the SO4 ion, Okay, now it does help, and you do need to know this, I think, the formula of the SO4 ion and the charge on the ion. Okay, so it's a sulfur and 4 oxygens. That makes the ion up. Now, all those 5 atoms, 1 sulfur and 4 oxygens, when they're bonded together like that, the whole thing has a 2 negative charge. So here, we've got Al3+ and SO4 2-. So we've got 2 negatives, 3 positives. We need more negative. So let's have another sulfate ion, SO4 2- ion. Okay, I've now got 3 positives and 4 negatives. Okay, so I've got not enough positives, so I need more positives, Al3+. I've now got 6 positives and 4 negatives, so I'm going to need another sulfate ion. Notice every time I draw another sulfate ion, I draw a whole nother SO4 2-. Okay, now it's 6 negatives. Now this all balances. So I've got Al2, I've got 2 aluminiums. Now, writing this sulfate is really important. So many students now will write SO, and they'll count 1, 2, 3, and they'll put a 3 down there. That's nonsense. is SO4, SO4, SO4. Okay, but we've got 3 of these SO4s. Now the only way we can do that with these more complex anions, when an anion is made of more than one element, and if we have more than one of them, we have to use brackets. We put brackets around it, and then we put the 3 outside it. So it has to have the 4 inside the bracket because it's SO4, and the 3 outside the bracket because there's 1, 2, 3 of them. Okay? So writing the balanced symbol equation for aluminium reacting with iodine. This involves us putting together what we've learned before with our balancing equations knowledge. Now, a lot of people when writing see this, they see the word balanced equations, they think they start to panic because they think they can't balance equations. But the reality is there'll often be 3 marks for a question like this in the exam, 3 marks for a question like this in the exam, and only 1 is for balancing. The other 2 is for getting the formulae correct. Well, aluminium, the formula is simply the element. Metals, the symbol for the equation is always the element. Iodine, that's a non-metal, it's a diatomic molecule. The diatomic molecules are fluorine, chlorine, bromine, iodine, oxygen and nitrogen. And you can always see that's an upside down L on the periodic table there. So if you ever write these in an equation, these elements here, it's always with a 2 after it because they're diatomic. There's one other element, that's hydrogen. That exists in the diatomic way as well. So if you write hydrogen equation, it has to be H2. So these are the only ones you write with a 2 after them in equations, and you need to remember them. H2, N2, O2, F2, Cl2, Br2, I2. So down here, iodine, plus I2. Okay, we now have an arrow because a reaction has occurred and it's going to make aluminium iodide. Aluminium reacting with iodine. The ending is "ide" because it's aluminium and iodine only. So the formula of that, we need to know the charges on the ions, just as we did for all the previous ones a moment ago. So it's going to be Al3+ because aluminium is in group 3 of the periodic table. Iodine, group 7 of the periodic table, single negative charge. So I-. So we've got to get these charges to balance, 3+, I-. We're going to need 3 minuses. So we need I-, I-. So that's going to be Al, I, 1, 2, 3. Now the reality now is Al, I, 3. If this were an exam question, we'd now have 2 out of 3 marks because we've got these formulae correct. Okay, we haven't balanced it because we've got 2 iodines there and 3 iodines there. It's not balanced, but we've got 2 out of the 3 marks. The moral of the story is get the formulae right and then you can try to access the balancing mark. So to balance, 1 aluminium there, 1 aluminium there, that's balanced. Forget the aluminiums for a moment. 2 iodines there, 3 iodines there. That's not balanced. Now 2 and 3 are never going to go into each other, so we have to find the first common multiple. That is going to be 6. So we're going to need to have 6 iodines on both sides. If you think about it, hopefully you can figure out why. So we're going to need 6 iodines here. So to get 6 iodines, I'm going to need a big 3 before it. 3 times 2 iodines is 6. Okay, so to get 6 iodines over here, I've got I3 there. I'm going to need a big 2 before that. 2 times 3 is 6, and that's hopefully why you can see you need 6 iodines. Because there's no other numbers I can get in there that are small. There's no numbers I can get there that are smaller that equal these numbers of iodines out. In putting a 2 before this, we've changed the number of aluminiums, so I need a 2 there.